keep subheading java.util.concurrent java.util.concurrent package java.util.concurrent package. Okay, sir, here just observe, in the last sessions we covered synchronized keyword. Regarding synchronized, so there are n number of problems we faced with the synchronized. Can you tell some problems? The biggest problem is performance is going to be down. Second problem is, if we are not using synchronized keyword properly, there may be a chance of deadlock problem. Regarding deadlock, why deadlock came? Synchronized keyword is the only reason for deadlock situation, right? Sir, to overcome these problems, java.util.concurrent locks package came into the picture. Okay, of course, basically java.util.concurrent package. In that sub package, locks is there. I will explain. Sir, what problems we faced with the traditional synchronized keyword? There are several problems are there. The first, here let me summarize all the problems whatever we have. So let me summarize that. First thing, sir, I want to try, I have to get the lock. Suppose lock is not available, I want to get the lock. Suppose lock is not available, then my thread has to wait until getting lock. Correct, right? Until getting the lock. Sir, when I will get the lock? I don't know, maybe within 1 minute or 10 minutes or 1 hour or 10 days also, I don't know that. Until getting the lock, I have to wait, that's all. Sir, I don't want this type of thing. I want to try for lock. If it is available, please provide. If it is not available, I won't wait. I will execute alternative operations. Are you getting? I will execute alternative operations so that my waiting time won't be there. Performance of the system by default will be improved. This type of flexibility by default are not there with the traditional synchronizer keyword. Correct or not? Sir, suppose I want lock. Until getting the lock, you should wait. That's all. No alternative at all. Array, if you have lock, please provide. Not available, let me know so that I will execute alternative operations. Sir, if the bus, I'm waiting for a bus. Assume that. So, I'm not in the traditional synchronizer keyword. Until getting the bus, we should wait. That's all. No alternative at all. Are you getting? Suppose here I will ask, bus is available or not? Sir, bus is, if available, immediately I will get into the bus and I will go. If a bus is not available, I won't wait for the next bus. What I will have some alternative mechanism. With that, I will continue my execution, which is the more flexible to the programmer. Second approach, right? Are you getting? The second thing by default not there with the traditional synchronizer keyword. Simple. In the second, if L dot try lock, L dot try lock was just a try for the lock. If you have the lock, then you will get and execute safe operations, right? Sir, you have lock, that's why L dot try lock. If you got, execute safe operation. Else, sir, lock is not there, I didn't get. If lock is not there, you didn't get, no problem. Perform alternative operations and continue further. Are you able to get right? Okay, so this is what you people should aware. This type of flexibility not there in the case of synchronizer keyword. Here for right, one problem. So if we are not required to wait, if lock is not available, is there any question of deadlock situation? Is there any question of deadlock situation? No, there is no waiting time. No waiting time is nothing but no question of deadlock. In the java.util.concurrent package or concurrent.locks package, there is no question of deadlock. So if I use this type of concept, right, okay, problem by default got solved. Second one, sir, suppose if multiple threads are waiting to get the lock, sir, T1, T2, T3, 3 threads are waiting to get the lock. Lock is available, assume. Lock is available like. Sir, now which thread is going to get the lock? Is there any, which thread is going to get in the lock? Do you have any idea? Maybe T1 or T2 or T3 based on thread scheduler will tell. Sir, I don't want this type of thing. I should, T1 has to get the lock, or T2 has to get the lock. Fairness policy is there. Longest waiting thread has to get the lock first. this type of guarantee you can't provide in the case of synchronizer keyword. But in the logs, so there is one flag is there. If I set that flag, longest waiting thread by default is going to get the chance. This one is nothing but fairness policy. Fairness policy is not there. So be a bit fair is nothing but don't do fraud. Be a bit fair is nothing but we can use fairness policy. If we set a fairness policy, then automatically longest waiting thread will get the chance, will get that lock. But in the traditional synchronizer keyword, there is no such type of terminology. Are you getting that? Next, sir, how many waiting threads are there to get the lock? How many waiting threads are there to get the lock? Is there any method to identify that? Nothing. Are you getting? Was 4 waiting threads are there, 5 waiting threads are there. There is no API. How many waiting threads are there? Like there are n number of problems are there with the traditional synchronizer keyword. Are you getting? So to overcome these problems, we should go for what? java.util.concurrent.logs package, okay, which came in the 1.5 version, right? Once you start using this package, okay, then synchronizer keyword is nothing but you can give left and right to that, not required to use synchronizer keyword anymore. But very unfortunate, most of the programmers don't know about that, so still the people are using what? Synchronizer keyword only. Getting the points, right? Keep submitting. The problems with traditional synchronized keyword. The problems with traditional synchronizer keyword. Traditional synchronizer keyword. Traditional synchronizer keyword. Okay. First one. We are not having any flexibility. We are not having any flexibility to try for a lock. We are not having any flexibility to try for a lock. Without waiting. To try for a lock without waiting. So are you getting? There is no flexibility to try for lock without waiting. Second one. Sir, suppose sometimes, do you know, sir, my requirement is I want lock. In the traditional synchronizer keyword, what will happen? Until getting the lock, compulsory we should be in waiting state. Sometimes what I will specify, sir, I will wait for 10 minutes. Within 10 minutes lock is not there. Lock, I didn't get the lock. Then I will continue my execution with alternative operations, right? Like we can try for lock and we can specify maximum amount of waiting time. In the traditional synchronizer keyword, there is no such type of terminology. In the traditional synchronizer keyword, what will happen? Until getting the lock, I should wait, no alternative at all. Are you getting? Second, there is no way to specify. There is no way to specify maximum waiting time. There is no way to specify maximum waiting time. For a thread to get lock. For a thread to get lock. So that to get lock. So that thread will wait. Until getting the lock. Until getting the lock. Thread will wait until getting the lock. Until getting the lock, which may creates performance problems. Which may creates performance problems. Which may creates performance problems. Which may cause deadlock. Which may create performance problems. Which may cause deadlock. Okay. Second. Next, third one. If a thread releases a lock, then which waiting thread will get that lock? Then which waiting thread If a thread releases the lock, then which waiting thread will get that lock? Then which waiting thread will get that lock? Which waiting thread will get that lock? Will get that lock? We are not having any control on this. We are not having any control. We are not having any control on this. We are not having any control on this. On this. Okay. Next, fourth one. There is no API. There is no API to list out. There is no API to list out all waiting threads. There is no API to list out all waiting threads for a lock. There is no API to list out all waiting threads for a lock. To list out all waiting threads for a lock. For a lock. All waiting threads for a lock. Okay. Next one, here legend. Up to these four we covered. One more thing is there. Sir, synchronizer keyword, how we can use? We can declare method as a synchronizer. One possibility. Second possibility, inside a method we can take which one? Synchronized block, synchronizer of this or something like this. Synchronized keyword applicable either at method level or within the method. Are you getting? Sir, sometimes what will happen is across multiple methods I want synchronizer. Within a method only we can talk about synchronizer, but across multiple methods I want thread safety. Suppose here see, sir, m1 is there. Within m1 I am calling m2 method. m2 is there. Here just observe m2 code. Sir, I want a lock here. I want lock here, and I am calling which method? m2 method. Within that m2, here onwards lock is no longer required. Are you getting? I require the lock here, and inside a method, another method, I want to release a lock. Okay, this here these multiple threads are allowed. This part multiple threads are allowed to operate, but this point onwards until this point I want a lock. Can you tell how you can define synchronizer for this? Are you getting? Synchronizer terminology applicable only at a method level or within the method. Across multiple methods we can't. But there is one flexibility there in java.util.concurrent.locks package. Simple. Where you want lock? Sir, I want lock here. L.lock. Now thread got the lock, then only it will continue. Sir, here onward lock is no longer required. What I will do? L.unlock. That's all. Are you getting? Across multiple method synchronization nature, by default I can able to achieve. This one is not possible with the traditional synchronizer keyword. Correct or not? Okay, this is. So synchronizer keyword always talks about a method or within the method, but across multiple methods synchronizer keyword can't help. Are you getting? But this one we can able to solve by using which concept? Lock. java.util.concurrent.locks package talks about this. Okay, add fourth. Next. The synchronizer keyword compulsory we have to use. Synchronizer keyword compulsory we have to use. Compulsory we have to use either at a method level or within the method. Either at a method level or within the method. Either at method level or within the method. Either at method level or within the method. Either at a method level or within the method. And it is not possible to use across multiple methods. And it's not possible to use across multiple methods. Not possible to use across multiple methods. That's all. Are you getting? So total how many problems we list out? Five problems. To overcome these problems, some people introduce which concept? java.util.concurrent.locks. Concurrent.locks package in which version? 1.5 version, right? Okay, add next paragraph. To overcome these problems, Some people introduced some people introduced some people introduced java.util. Some people introduced java.util. Concurrent.logs package. Java.util.concurrent.logs package. Java.util.concurrent.logs package in 1.5 version. In 1.5 version. Okay, sir, not only these problems, don't feel only alternative to synchronizer. So this package also provides several enhancements to the programmer, okay, to get more control on concurrency. Are you getting? Try without lock is nothing but try, so without waiting, this type of extra enhancements also, more flexibility to the programmer. The required enhancements are nothing but where this package also provides. Are you getting? Add it also provides several enhancements to the programmer. It also provides several enhancements to the programmer. It also provides several enhancements to the programmer, to the programmer to provide. It also provides several enhancements to the programmer to provide more control on concurrency. To provide more control on concurrency. To provide more control on concurrency. That's all. Are you getting? So this is about the basic introduction. Okay, what is the need of this new concept, right? Now in this we have to talk about one interface and one implemented class. So interface is lock, and a lock itself is an interface. Okay, implementation class is re-entrant lock. Are you getting right? Only two things we require to talk: lock interface and what? Re-entrant. I covered some methods. Try lock. Are you getting? Try lock. These methods, lock, unlock methods, these methods are available where is nothing but lock, and implementation class is nothing but re-entrant lock. Keep submitting lock interface. Lock interface. Okay, add. So here just observe a lock object. Of course, its implemented class object is something like traditional lock object acquired by the thread in the case of synchronizer keyword. Are you getting? It is something like same. Sir, if I call synchronizer method, then thread required to get what? Lock. So there implicit lock, but here I am creating lock object explicitly. It is something like implicit lock only. Okay, this. But this lock provide extensive operations than traditional lock. Are you getting right? Sir, for this lock, how many waiting threads are there? Is it possible to know in the case of normal synchronizer keyword? Not there. But here I can talk, lock, how many waiting threads are there for you? Can you please list out? Is nothing but happily you can. Was now onwards, this lock is no longer required. L dot which method? Unlock method. Like more extra operations also by default we can able to get. Add lock interface. Add lock object is similar to lock object is similar to implicit lock. Lock object is similar to implicit lock acquired by a thread. Lock object is similar to implicit lock acquired by a thread. Acquired by a thread to execute acquired by a thread to execute synchronizer method, or synchronizer block. To execute synchronizer method or synchronizer block. To execute synchronizer method or synchronizer block. Next, lock implementations. Next point, lock implementations provide more extensive operations. Lock implementations provide more extensive operations than traditional implicit locks. Traditional implicit locks. Okay, that's all. Next, keep submitting important methods of lock interface. important methods of lock interface, important methods of lock interface. Okay, sir, first method, okay, listen, sir, first method, void lock. So to acquire a lock, sir, I want to get this lock, L dot lock, the thread here, see, L dot lock. Sir, this line executed by which thread? Assume that main thread trying to get the lock of this object, trying to get the lock. If lock is available, immediately it will get and continue save. If lock is not available, it will wait until getting the lock. In the traditional synchronizer keyword, what happened? Same thing is nothing but lock method. Are you getting? Okay, add void lock. We can use this method. We can use this method. We can use this method. Okay, to acquire a lock, acquiring a lock. If lock is already available, if the lock is already available, then immediately current thread will get that lock. If lock is already available, then immediately current thread will get that lock. If the lock is not already available, then it will wait until getting the lock. It is exactly same behavior of traditional synchronizer keyword. Correct or not? Traditional, it is exactly same behavior of traditional synchronizer keyword. Okay, so this is about what? Lock. Sir, if lock is available, immediately I will continue. If lock is not available, then what I will do? I will wait until getting the lock. In the traditional synchronizer, what happened is the same. Second method, here listen, more flexible. This type of support is not there in the traditional synchronizer keyword. Sir, boolean, okay, try lock. Do you know boolean try lock? Simple point. Sir, there are n number of people. Listen this point very carefully. Out of 100 people, 100% of the people are there. Out of 100, everyone having, there are a number of ideas in their mind. Again, everyone having, even a person who is beggar on the road, he is having a number of ideas are there with him. Okay, a number of ambitions, a number of ideas are there in his mind. Oh, I want to do this and so on. Is nothing but out of the only 5% of the people, okay, will try for that. Are you getting right? Will try. Sir, whether you may succeed or not, just try once. Are you getting? How many people are going to try? Very less number of people. Okay, these 5% only we are seeing the crowd out of 120 crores of Indians. How many people are going to try to start one software company? Very less. But every software engineer having the idea, why don't you start one software company? Every software engineer having, if I am the owner of the software company, it will be good. Is nothing but like, everyone having this point in their mind, every working person having this point. But how many people try to start software company? Very less. Even if I am considering that 5% also I can't give. Okay, assume 5%. 5% of the people only will try. Once they try, immediately n number of problems are going to invite. Okay, so in the once we start, n number of problems are there. Even at the beginning, do you know, very horrible number of problems will be there. So by seeing those problems, is nothing ma 4% of the people is nothing ma, I can't do this, is nothing but like just the 1%. Anyway, started right. Why I have to live in the middle? ఏదైతే అదైతే, let me continue. ఏదైతే సో let me continue until last. Just only 1% of the person is going to continue. That person is the successor. Are you getting that? Just try. You know, best example for this is the sea. సముద్రం అంటాం కదా, నా sea. సముద్రపు అలలు వస్తూ ఉంటాయి కదా, sea, what we call waves, is nothing but అలలు వస్తూ ఉంటాయి కదా. Seems to be big, is nothing but once we entered into the sea, is nothing but it is a big problem like. But these kind of thing, all these at nearby, what we call ఒడ్డుకి చాలా దగ్గరలోనే. Once if we go into the middle of the sea, there is no such type of things. So everything very plain, normal, there is no movement in the water like. అవునా? కరెక్టేనా? ఇది ఎక్కడో విన్నట్లు గుర్తు. Is it correct? కరెక్టేనా? జస్ట్ అట్ నియర్ బై, at the beginning, ఒడ్డుకి మధ్యలో, at the beginning only this type of thing is there. Once you entered in the middle of the sea, is nothing but nothing will be there. It's a very common, normal like. The same thing, 4% of the people are going to be dropped by saying initial problems. But once you cross those, happiest life by default will be there. But very unfortunate, out of 1 crore people, 99 lakhs, some 99,990 members, nothing but going to be dropped just based on the year only. Just the 10 people who are going there is nothing but, that's why out of 120 Indians, 120 crore Indians, just 10 or 15 software companies are there, Indian based software companies in India. Getting that? Okay, this is small thing. Okay, hurry, just try once to get the luck. What is the problem? If you are not getting, no problem, just try once. That thing must be required. Are you getting? Just try once. What is that method? Boolean try luck. If it is available, then immediately I will. Hurry, if it is available, then immediately I will get that. If it is not available, what will happen? I won't wait. I will continue with alternative operation. So if it is available, returns true and get that. If it is not available, returns false. Once it is a false, I won't wait, I will continue further. Then how we can, sir, try for the lock without waiting. Try for the lock without waiting. Then how to use this one? Simple. Even I spell out this one. If on the lock object, L dot, what is the method? Try lock. If you got the lock, try lock. If you got the lock, perform. If you got the lock, perform safe operations. Perform safe operations. Else, perform safe operation. Else, if lock is not there, else, so perform. Else perform alternative operations. Perform alternative operations, right? I hope you people got clearly. L dot try lock. If you are getting the lock, perform safe operations. Else perform alternative operations, right? Okay, add. Second method, Boolean try lock. Boolean try lock. To acquire the lock without waiting. To acquire the lock without waiting. To acquire the lock without waiting. Next, if the lock is available, then the thread acquires that lock. And returns true. Then the thread acquires that lock and returns true. If the lock is not available, then this method returns false. And can continue its execution without waiting. and can continue its execution without waiting. Can continue its execution without waiting. Without waiting. Continue its execution without waiting. In this case, thread never be entered into waiting state. In this case, a thread never be entered into waiting state. Thread never be entered into waiting state. Never be entered into waiting state. Okay, that's all. Now take this one. Take this. If L dot try lock perform safe operations, else perform alternative operations. Else perform alternative operations. Completed, right? Alternative operations like. So, have you remembered what is the first method? First method is what? L dot lock. Now legend this one. L dot lock. Sir, if lock is available, get. If lock is not available, wait until getting the lock. This is the behavior. L dot try lock. Sir, L dot try lock. If lock is available, get that. If lock is not available, don't wait. Continue your execution. Try lock. Then the medium method. Try for the lock. If it is available, get. If it is not available, don't continue immediately. Wait for some time. At least 1 hour wait. Still, if you are not going to get the lock, then continue. Is nothing but then how you can L dot try lock. L dot try lock. How much time you want to wait? 1 hour, right? Specify 1 hour only. One number. This 1 means what? Hour or minute or milliseconds, nanoseconds, like how you can 1 comma time unit dot hour. Are you getting? Time unit dot hour. Sir, hours, like time unit dot hours. Assume that. Okay, sir, can you please? I will wait 1 hour. Still, if I am not getting the lock, I won't wait. I will continue further. Is nothing more. With the time period also we can call the method. Are you able to understand, right? Okay. So add third method. Boolean. 1 minute. Third method. Boolean. Try lock. Boolean try lock. Long time. How much time? Long time. Next, time unit. Boolean try lock, long time. Time unit. Okay. So 8. If lock is available. If lock is available, then the thread will get the lock. And continue its execution. Will get the lock and continue its execution. Next. If the lock is not available, then the thread will wait. Until specified amount of time. Still, if the lock is not available, then thread can continue its execution. Then thread can continue its execution. Thread can continue its execution. Thread can continue its execution. Execution can continue its execution. Like, are you able to understand, right? Okay, this is, sir, now here just so better to keep time unit, keep subheading time unit, time unit, time unit. Do you know what is the time unit? Okay, time unit. Do you know time unit is an enum? Enum is nothing but what? A group of constants. Time unit is an enum present in java.util.concurrent package. What values are there? Okay, hours, minutes, seconds, milliseconds, nanoseconds, microseconds, even day also, days. Okay, these many days, these many hours, these many minutes, these many seconds, these many milliseconds, these many nanoseconds, these many microseconds I want to wait. These are the values, allowed values for the time unit. Let me cross check. So java.util.concurrent.time unit. It is not there in java.util.concurrent.logs package. It is there where java.util.concurrent package only. Have you observed? Here it is showing. Of course, it is internally interpreted as abstract class, but actually, strictly speaking, it is enum. Internal API level, it is the enum with what values? Have you observed? Nanoseconds, microseconds, milliseconds, seconds. Okay, so minutes, hours, days is nothing but like these are the allowed values, right? Okay, add. Time unit is an enum. Time unit is an enum. Present in java.util. Present in java.util.concurrent package. Java.util.concurrent package. Okay, so better to take in this style. Enum time unit with what allowed values? Do you know? Here just observe nanoseconds. Sir, here in the middle, have you observed? Underscore symbol is there. Nanoseconds. Next, microseconds. Next, milliseconds. Next, seconds. Next, minutes. Next, hours. Days. That's all. Are you getting? Nanoseconds, microseconds, milliseconds, seconds, minutes, days, like. Okay. Completed, I hope. Days. This is the enum present in java.util.concurrent package. So log interface present in which package? java.util.concurrent.logs package. But this one present in java.util.concurrent, because while using these things we require to write import statements, right? Compulsory. Make sure. Okay. Next example. If L.trilog 1000, time unit dot milliseconds. Time unit dot milliseconds. Sorry if I'm getting the log, something like this one. L dot time unit dot milliseconds. Okay. Next, are you getting right? This is a trilog with a time period, Anna. With a time period. Okay. Next method, here see. Next method, better to here have a look. Void lock interruptably. What this one? Lock interruptably is simple. If the lock is available, then it will get. If the lock is not available, then it will wait. It will wait. While waiting, if the lock is not interrupted, then only thread will get the lock. If the thread got interrupted, then it won't get the lock. Are you getting? Lock interruptably. If the thread is not interrupted, then only thread can get the lock. If the thread not interrupted, if it is interrupted, then thread won't get the lock. Are you getting? So add this method. Void lock interruptably. Void lock interruptably. Take special care spelling interruptably. Add acquires the lock. Acquires the lock if it is available. Acquires the lock if it is available. If it is available. Acquires the lock if it is available. And returns immediately. And returns immediately. Acquires the lock if it is available and returns immediately. Immediately. Next up. If the lock is not available. If the lock is not available, then if the lock is not available, then it will wait. Then it will wait. Then it will wait. Wait. Next up. While waiting, if the thread is interrupted, while waiting, if the thread is interrupted, while waiting, if the thread is interrupted, then thread won't get the lock. While waiting, if the thread is interrupted, then thread won't get the lock. Then thread won't get the lock. Won't get the lock. Won't get the lock. That's all. Are you getting? Next up. But the next method is void unlock. Void unlock. Next method, void unlock. Void unlock to releases the lock. Void unlock to releases the lock. To releases the lock. Now here one small twist is there. Suppose L.lock. Now assume that this line executed by main thread. Now main thread got the lock. Perform safe operations. And then L.unlock. Now is it meaningful or not? Yes, I am getting the lock and then I am unlocking. Suppose main thread directly calls at the beginning only L.unlock. Or main thread not having the lock at the beginning. If you want to call unlock method on any lock object, compulsory the current thread should be owner of this lock. It's nothing but current thread should have the lock. I am not having the lock, but still I am calling unlock method. Are you getting? I am not having the lock, still I am calling unlock method. What will happen? Immediately runtime exception saying illegal monitor state exception. Illegal monitor state exception by default we will get. Are you getting? To call unlock method, compulsory the current thread should be owner of that lock, or current thread should acquire that lock. Otherwise, immediately what will happen? Illegal monitor state exception. Add this point also. To call this method, compulsory. To call this method compulsory. Current thread should be. To call this method compulsory current thread should be. To call this method compulsory current thread should be owner of the lock. Compulsory current thread should be owner of the lock. Otherwise we will get runtime exception saying. What is that exception? Illegal monitor state exception. Otherwise we will get runtime exception saying illegal monitor state exception. Illegal monitor state exception, like illegal monitor state exception. by default we are going to get. So I hope is the terminology the clear for you, right? That's all. These are the methods present in which interface? Lock interface. Total how many methods are there? Can you please cross check? 4 or 5? 5 methods. Lock, try lock without time period, try lock with time period. So 3 next lock interruptably. Last one is nothing but what? Release method or unlock method. That's all. These are the 5 methods present in lock interface, right? Now the implementation class for that is nothing but which one? Reentrant lock. Keep submitting. Reentrant lock. Reentrant lock. Reentrant lock. Lock.